Hello and welcome to Easy Projects. So I just reached 10,000 subscribers, and let's keep the tradition alive and go ahead and make another plaque like I did for the 5,000 subscribers. You can see this one actually had a little accident. I spilled some flux on it, and apparently the alcohol in the flux just totally ruins the acrylic. But this time we can make it on the DIY 3D printer that I just made. It's not completely finished yet, as you would know if you follow the series, but it can print, so we'll go ahead and use that. I designed a little trophy in CAD, and we'll print that out and see how it looks like. It's a little bit bigger than the first test print, so we should get a better idea of how the printer is printing. But first I would like to thank everybody who subscribed to my channel and watched the videos. And also thanks to everybody who purchased a t-shirt from Teespring. The campaign has ended and we sold 16 t-shirts, so that's better than last time. But let's go ahead and get the printer started, and we'll get back after that. So the first print actually failed halfway through because the stepper motor for the extruder got so hot that the PLA plastic was getting soft inside the drive mechanism here. So I had to add a PC fan to it, and this spinning is actually enough to keep this very cold. It only gets like 40 degrees then, and before it got like, I don't know, 60, 70 degrees. So the first layers are printing nicely, as you can see, and after I switched to that new glue stick, there's no problems with it sticking to the bed. We're printing in PLA mainly because the ABS can only stick to a heated bed, and I didn't get that made yet. We're also printing quite a lot faster than last time. The infill here is printing at 125 millimeters per second, and the inner perimeters, as you see now, are printing with 100 millimeters per second, and then the outer perimeter, this one, is printing with 50 millimeters per second. I do believe we can go a lot faster than this, but I just want to take it one step at a time. So here it is. I just went and cleaned it up with a utility knife and got rid of all the stringiness. We could probably avoid that by tweaking the software a little bit to give it more retraction. Apart from that, it printed okay, and if you look at the bottom layer and also the top here, it looks very, very nice, but it has a little problem with the Z-axis. You can see it shifts a little bit, so we get these funny patterns. It's not very much, maybe like 1/10 of a millimeter, but it's enough that it's distracting to look at. I'm also pretty sure that if we go ahead and measure the distance from these patterned lines here, we will get exactly 1.75 millimeters, which is the thread pitch of the lead screws over here. And the easiest way to see it is probably down here. And we get 1.75 millimeter. So the problem would be that this rod is not running 100% true. So it forces the build plate with it. And then these fin rods here can bend a little bit. Or maybe it just wiggles the whole build plate back and forth like this. So what we'll have to do to get rid of that problem is to fix these brackets so that this cannot flex anymore. And then maybe we'll also have to change the lead screws to some without any run out and play in them. So there we have it. I hope you liked it, and I don't know what we should aim for next. Perhaps 25,000. I don't know. And yep, it's a couple of days ago since I hit the 10,000 subscriber mark, but I was out shopping, so I didn't have time to finish the video. I've been wanting a small lathe since I got the milling machine, and I wasn't really able to find any used ones this small until now. There were some good larger ones, but they were much more expensive. This one I got at a good price, I think. This one is very small, but there's no visible wear on it anywhere. Even the tailstock there's no play in it whatsoever, even when it's loose. The only thing I've used it for so far is to turn down the end of this aluminium rod. The good thing about this one, and what I've been looking for, is that it has a gearbox, so you don't have to constantly change the gears in the side here. It does have a belt for speed though, and also if you want to do threading you have to change the gears, but just for general turning we can just use this to change the feed rate. And again, thanks to everybody for subscribing and watching the videos. And I'll catch you soon for the next one. See you.